Hello everyone, this is Pravesh Malviya. Now we are going to discuss about the losses in the transformer. So there are several losses. Because of that, whatever power we feed to the input side of the transformer, we do not get the same amount of power from the output side. It is because of these losses. So there are four losses actually in a transformer: iron loss, copper loss, stray loss, and dielectric loss. So starting with the iron loss is also known as the core loss. It has two types: hysteresis loss and eddy current loss. Iron loss or core loss. So the name actually represents that it is occurring in the core of the transformer. It is occurring in the magnetic circuit of the transformer. Iron losses are caused by alternating flux in the core of the transformer. As this loss occur in the core, it is also known as the core loss. The iron loss is further divided into hysteresis and eddy current loss. So the iron loss is actually the result of alternating flux in the core. So now coming to the hysteresis loss, we know that in the input side of the transformer, in the primary winding, we fed the alternating current. When alternating current is supplied to the primary winding, it sets up a magnetic flux in the core, and that flux is also of alternating nature. It means the flux actually changes its direction and magnitude, and in each half, in positive half as well as in negative half. So what happens, this reversal of flux in the core, in any part of the core, this reversal of flux actually takes some amount of power, and this loss is known as hysteresis loss. So what is hysteresis loss? The reversal of flux consumes some amount of power, and that consumed power is actually known as the hysteresis loss in the transformer. So how it can be minimized? This is the formula of the hysteresis loss. Now this can be minimized for a constant voltage. This can be minimized by minimizing the frequency of the alternating supply. If we decrease the frequency, the reversal rate of the flux also decreases, thus hysteresis loss can be decreased. But for a fixed frequency, say 50 Hz, the transformer will have a fixed hysteresis loss. Now coming to the eddy current loss, this loss is the second type of the core loss. We know that the core of the transformer, this core of the transformer is made up of some metal. So metal is a conductor, and when a conductor is subjected to a variable magnetic field, some amount of EMF is induced across the ends of the conductor, and if the conductor makes a closed path, then a current will flow through it. So what happens when this metallic core is when subjected to reversal of magnetic flux, that is the alternating flux, and current is set up and it flows in the core of in this metallic core. So this current which actually flows in the core is known as the eddy current, and this flow actually needs some amount of power. So it's a loss, and this loss is known as the eddy current loss. And then this eddy current loss can be prevented by making thin laminated sheets of the core. We have seen in laboratory a transformer, the core of a transformer is made up of thin laminated sheets. It's not made up of a single metal. When it is made up of thin laminated sheets, the eddy current loss is actually reduced. Then coming to Now here we can see that the eddy current can be minimized with the help of reducing the frequency and T, where T is the thickness of the laminations in meters. So if we decrease the thickness of the lamination, here we have decreased in the third diagram. So if we decrease the thickness of the laminations, this eddy current loss can be reduced. Now coming to the second loss, we have completed our first loss, that is core loss, iron loss, which was divided into hysteresis as well as eddy current loss. Now coming to the second loss, that is copper loss. Copper loss is also known as ohmic loss. Now the first loss, that was the iron loss, it was a magnetic loss, because it was in the magnetic part of the transformer, it was in magnetic circuit of the transformer, so we can call it as a magnetic loss. But the second loss is actually an electric loss, so obviously it will be happening in electric part of the transformer. So we know that the transformer actually has two electric circuit. With the same diagram we can see here that here is having a primary winding and a secondary winding, and both electric circuit have current flowing in the winding. So when current flows in the primary winding I1 and current flows in the primary winding I2, so both the windings are actually made up of some metal, and both the windings will have their own resistance. Say primary winding has the resistance R1, secondary winding has the resistance R2. When R1 when the current in primary winding I1 flows through the R1 resistive primary winding, there will be an I square R loss in the primary winding. And when current flows through the secondary winding, and secondary winding has also some on its resistance, so there will be also a copper loss, I square R loss. So this I square R loss is actually the copper loss in the winding. So here we can see, when we talk about total copper loss, it is the sum of the copper loss in the primary winding, that is I1 square R1, and the sum and copper loss in secondary winding, that is I2 square R2. So this is the total copper loss. And how it can be reduced? This loss can be reduced by reducing the current, but we cannot reduce the current for several operations. So better that we reduce the resistance of the wire. So it's better to take low resistive material for making the winding at the time of manufacturing the transformer. Then coming to the third loss, stray loss. These two losses, stray loss and dielectric losses, are actually very low in their own magnitude, so they can be actually neglected. So what is stray loss? The occurrence of these stray losses is due to the presence of leakage field. The percentage of these losses are very small as compared to the iron and the copper loss, and they can be neglected. So the percentage, the amount of stray loss is actually very low, so we can neglect it for further calculations. Now coming to the dielectric losses. Dielectric loss occurs in the insulating material of the transformer, that is in the oil of the transformer or in the solid insulations. When the oil gets damaged or its quality decreases, and because of this, efficiency of the transformer gets affected. So a transformer can be a three-phase transformer or a single-phase transformer. So we have to match its insulation requirements. So if insulation requirements gets disturbed, so efficiency also gets affected. But these two losses, stray and dielectric losses, have a very low percentage as compared to iron and copper loss, so they can be neglected in further numericals and calculations. So we studied about losses in a transformer. So basically there are 4 losses: iron, copper, stray and dielectric losses. So this is all about transformer losses. For any question and query, you can contact me anytime. Thanks for watching.